Hello viewers, in this video we are going to talk about histograms. Also, I am going to show you how to plot histograms using ggplot function. So what is histogram? Histograms are graphs of a distribution of a single continuous variable designed to show centering, dispersion, that is spread, and shape, that is relative frequency of the data. So remember, histogram is always used on a single continuous variable to check the distribution of the single continuous variable, and it tells you the three important parameters about that variable. The first is the mean or the centering of the data, where the mean is located. Then second is the how that variable is spread across the mean. That means how it is dispersed. And the third one is the overall shape or the relative frequency of that variable. So there is a lot of information that you get after plotting the histogram of single continuous variable. Okay, and histograms can provide a visual display. Now consider that you have the data set running into millions of rows. So looking at the tabular data or the spreadsheet data doesn't really tell you anything. So you want to check the distribution visually. In that case, the histograms are used. So now in order to show you how to plot the histogram, we are going to work on the reverse data. This reverse data is from the base R datasets package. And this data is about the length of the rivers in miles of 141 major rivers in North America. So let me start by loading the tidyverse library tidyverse, and I will also need the datasets library, so library datasets, and let's have the first look at the reverse data. So head rivers. Now here you can see that the reverse is a numeric variable, and we are interested in understanding its distribution using histogram. Now, since ggplot function works with data frame and table objects, so we will have to convert this reverse variable into data frame object. Right now, I'm going to create the object called df_rivers. So this will be my data frame object, data.frame rivers, and finally view. Right. Now you can see that this data is now transformed into data set, and we are ready to go with the histogram. Now in order to create the histogram, we will use geom_histogram function. Now let's start building the ggplot layers. So ggplot, the data I'm going to use is the df_rivers, and the aesthetic part will be the x-axis equal to rivers, because that's the variable we are interested in looking at its distribution. So x equal to rivers. Geom_histogram is the geometric object I'm going to use to plot the histogram. So let's see how it looks like. Now you can see that the histogram, the distribution of the rivers, the variable is right skewed. Looking at the histogram, you can see that it's a right skewed data. So in majority of the cases, the river length is lesser than 1,000 miles. However, there are very few rivers. You can see that there are very few rivers having river length more than 1,500 miles. So this is the overall distribution looks like, and this we can able to get immediately because of the histogram plot. Now, but this histogram looks very messy, right? So now we will make it more neat, more tidy. I'm going to use two arguments here, the fill and the color argument in the geom_histogram function. So let me use fill equal to white. That means I'm going to fill each bar with a white color, and I'm going to use a black color representing the boundary of each bar. Now let's see how the histogram looks like. Now you can see that the additional arguments that we have used, the fill and the color, we could able to get a more clean histogram, a more representative looks more interpretable. The histogram now looks more interpretable. So let's have a closer look at this histogram now. Now this histogram divides the x-axis into bins. So these columns that you see are typically called as bins in the histogram parlance. And counting the number of observations, and the y-axis is nothing but the frequency or the count of the number of observation in each bin. So the few observations that we can able to make from this histogram are, if you look closely, you will find that there are 8 bins in each interval. For example, between interval 0 to 1000, there are roughly 8 bins. So if I want to calculate the bin width, then I will have to divide 1000 by 8, which is equal to 125. So in this histogram, my each bin width is 125 miles. Okay, and if you look at the third bin, you will observe that there are around 38 rivers having the length between 250 to 375 miles. Now, how these numbers come, how the 250 miles come? Yeah, if you see that there are 2 bins before the third one, so you will have to add 125 twice. So that gives me 250. So the third bin starts with 250 miles. And if you add 125 to 250, because the bin width is 125, you will get 375 miles. So the third bin starts at 250 miles, ends at 375 miles, and there are around 38 rivers in this range, having the length in this range. That's how you interpret the histogram. And most of the rivers in the data have length between 125 miles to 1000 miles. So that's why you see more number of bins plotted on the left hand side of the graph than on the right hand side. And this is typically called as the right skewed data. And you will also see that the tail is pointing to the right. So that's a typical right skewed data that we have here. Now, as a good practice, the histogram is always shown with the mean value. So we can use another layer which will overlay the mean line on the histogram. Now let me show you that. So going back to our ggplot function, I'm going to create another layer, geom_vline, and x-intercept in this case will be the mean of the rivers, right? Will be the mean of the variable, in this case rivers. Okay, and then I'm going to use line width equal to 1 and line type equal to 2. Line type equal to 2 and color equal to red. So let's get it. Yeah. So you can see that the dotted line is the mean line, is the mean of the data, right? And since it's a right skewed distribution, the mean value is pulled towards left. Okay, perfect. Okay, moving on, we can also draw the smooth curves to show the general shape of the distribution. Now I can also draw the smooth curve on this histogram. It gives me the general shape of the distribution. Smoothing a histogram into a curve helps us to see the shape of the distribution with the less jagged edges at the corners. Now, but please note here is that the smooth curve follows general pattern in the data, and don't try to match every bump and dip seen in the particular pattern. Okay, so this smooth curve can be drawn with the help of geom frequency polygon function. That's the geometric object, geom frequency polygon we would use. Geom frequency polygon function we would use. Okay, so let me copy this and let me now create geom underscore frequency poly. Then color I'm going to use is blue and line width equal to 1. Okay, let's execute this. So you can see the smooth curve and it immediately tells you the distribution of the data. Okay, so far we have used geom histogram function with its default parameters. Now, for example, by default, the number of pins is 30. But we can override this number by using binwidth argument. So in order to show you how to use the binwidth argument, we are going to use a different data set. We are going to use the old faithful geyser data. So head geyser. Now you can see that this data is about the eruptions from the old faithful geyser in Yellowstone National Park. Duration is eruption time in minutes and waiting is a waiting time for this eruption. Now we are going to draw the histogram for the eruption time. Okay, so let's again draw the histogram. So ggplot data equal to geyser, aesthetic equal to x on x-axis, duration, because we want to show the histogram of duration, and geom histogram is our geometric object. So you can immediately see that you have two modes here. It's a bimodal distribution. So let me change the color equal to black and fill equal to white. Yes, so you can see that it's a bimodal distribution. You have a higher frequency of 2 minutes eruption and also the higher frequency of 4 minutes eruptions. Now I'm going to change the bin width to 0.25 minutes. That means each minute will get divided into 4 equal size bins, each with 0.25 minutes bin width. And the second important argument is the boundary argument. The boundary argument is a bin position specifier. For example, if I use boundary equal to 2, that means I'm forcing a bin to break at 2 minutes. So let me show you these two arguments now and how the histogram looks like after using these two arguments. So starting with bin width equal to 0.25 and boundary equal to 2. Boundary equal to 2. Okay, let me execute this. Now you can see that between 2 minutes and 3 minutes, for example, there are 4 bins and each bin is having 0.25 minute bin width. And because also we use the boundary argument, we have also ensured that the bin we have also ensured that the bins are broken at 1 minute, 2 minutes, 3 minutes and so on. You can see that also in the histogram. Right? Okay, and finally let me use geom vline to show the mean of the distribution. X-intercept in this case will be the mean of the duration. Okay, line width equal to 1, color equal to red, color equal to red. So let me execute this. Fine, and yeah, let me now change the line type so that we get a dotted line type equal to 2. So should get a dotted line. Yeah, so here is the mean of the histogram. And finally you can also use the frequency polygon to check the distribution of this data. So let's use the frequency polygon. So let me copy this ggplot function and let me create a frequency polygon layers. Geom frequency polygon, frequency poly, color equal to blue, and line width equal to 1. Yeah, so let me execute, and you can see that it's a bimodal distribution. However, remember one thing is you will have to use the same binning structure as the histogram to get the right overlap of frequency polygon. So I'm going to use the bin width equal to 0.25 and boundary equal to 2, and here we go. I got the same frequency polygon overlaid on the histogram. Fine, perfect. So let's summarize. Histograms are graphs of distribution of single continuous variable designed to show the three things. First is centering, that means mean, then dispersion, that means the spread of the data, and the shape or the relative frequency of the data. We use histogram geometric object to create the histogram. Remember, the histogram divides the x-axis into bins, and on the y-axis you get the count of the number of observations in each bin. By default, the number of bins is equal to 30, but it can be changed using bin width argument. We also use the boundary argument to specify the bin position. And finally, we use a frequency polygon to draw the smooth curve to show the general shape of the distribution. Thank you very much for watching. Please leave your comments in the comment section. Let me know if you like this video and your suggestions to make these videos more interesting. Thanks again for watching, and I will see you soon.